So I want to give you a few hints regarding Lab 1. If you've gone through all the presentation material, this shouldn't be too terribly difficult. And so let's talk about what you're expected to do. So Lab 1 asks you to actually create an initial PLC fiddle program that causes two lights to flash, and it so happens that you need to have that in the second part, which is tied to creating an architecture and writing multiple PLC fiddle programs that represents different aspects of that architecture. As you saw in the presentation, creating multi-program applications, we want to define a high-level architecture to start with, and we want to use the mediator pattern. Essentially, it's the exact same thing that was in the presentation, previous presentation. But this time around, I'm going to create a module called Alarm Light Manager, because in this lab, you're asked to actually create two blinking light routines. And so I'm going to change the name of the one manager from the previous presentation to Alarm Light Manager. Also, you don't have to add an analog I/O subroutine to this lab, but beyond that, it's very similar. So I'm only going to do the I/O module portion in terms of what the architecture would look like, simply because I'm not going to give you the answer for all of them. But straightforward, here's the architecture for the I/O control. No, there's no analog part to it, but there is another push button as well as another light that's being added to this. And although the lab doesn't actually call out red or green lights or any colors, we're just going to go ahead and use red, green, and yellow, because there's the one routine where there's a single blinking light. And so one thing we want to keep in mind is that although PLC Fiddle doesn't actually connect to a real PLC or real hardware, we could still utilize what addresses we think we're going to be using. And I'll show that to you in the next slide here. And then we could also create our parameter tags, the tags that are going to be available to other routines. And so I'm going to go ahead and use these names. Okay, so as we look at a PLC fiddle implementation of our I/O module, specifically the digital I/O subroutine, we end up with something that looks very similar to the one that we created in the creating multi-program applications presentation, and I've given you a screenshot of both the Studio 5000 version as well as the PLC Fiddle version. And one of the things that I did for the PLC Fiddle version is that the tags that are actually associated with hardware I/O, I'm calling aliases. And I went ahead and used the actual hardware address that I intend to use in my PLC Fiddle. And I can call it that, for example, I:01 underscore alias. That's a legal name in PLC Fiddle. And that allows me to say, okay, that's actually coming from hardware. And then for the parameters, or the I/O parameters, I could go ahead and use names like PB1, PB2, PB3, red underscore 0, DIO, green underscore 1, DIO, and so on. And it's very similar to what I did in my Studio 5000 program. I'm using PLC Fiddle to test code that I could put in Studio 5000. So when I'm running this code in PLC Fiddle, it'll actually run. Now, I will say that the subroutine is relatively simple. And if you are wondering why I'm putting the hardware I/O in a subroutine, I would assume that when you had PLC2, you would have gone through a demonstration where they showed you that when you exit a subroutine, whatever state an output is in, it can get locked. And so I don't want to be entering and exiting subroutines in my program or my application across multiple programs and locking up my outputs. So I leave this routine running constantly with I/O parameters that are accessible by multiple programs, and then that way I don't have to worry about locking up my I/O. So this is basically part of your lab, and I've worked it out for you. So I need you to work on the other modules and subroutines to complete this. So what are you submitting to me? You should be submitting an architecture with an explanation of your I/O parameter tags that you are using from module to module. You should also give me a list of subroutines for each module, and I would also suggest at least a paragraph explaining how you see your code works. What you're being asked to do for this first lab is very similar to the program that was presented in the video creating multi-program applications. What we want to do for this lab is to review PLC1 and PLC2 concepts and add a new concept in PLC3 where we start to organize code functions and features. We also want you to develop your technical skills regarding your ability to read and troubleshoot PLC code. Most PLC code in industry is written using some kind of architecture like what we've discussed so far. The PLC Fiddle tool allows us to write and test these code pieces, and we want to be comfortable as we move into more complex coding and debugging in this course. And the code's going to get a bit more complicated as we move forward. So if you have any questions, please reach out to me sooner than later. We have a lot of material to cover in these 8 weeks, and I wish you the best of luck on Lab 1.